playing videos and audio. You know what have to call this structure. But some people do have animations and videos, and then I would have to call the tech guys, which is university stuff.
Hello everyone, can you hear me well? Yes? Cool. Okay, so let's start. Welcome, and let's just do that. So we're going to do a presentation called OpenShift as seen by the good, the bad, and the ugly. Okay, so the idea is to see a little bit of OpenShift from different perspectives, you know. We will see who are the good, the bad, and the ugly. We will discover that, okay? Those are the good, bad, and ugly. It's a movie for the millennials. Probably don't know about that, but it's a movie. Okay, and then just a quick intro on myself. My name is Karim. I work at Red Hat. So this is my GitHub, and also you can see my Twitter handle, although I don't use that too much, actually, to be fair.
And my name is Eduardo. I work at Red Hat as well with Karim on system engineering team. Those are my GitHub profile and my Twitter handle. I use it more than Karim does.
Yeah, sorry.
And to get started, let's do a quick survey on the knowledge of the people on OpenShift. So who knows what OpenShift is? Please raise your hands. Okay, almost everybody. Who has some OpenShift experience or who has created an OpenShift cluster? Okay. Who has deployed OpenShift in the real world, I mean in production, with a bunch of nodes?
Just two.
Okay, 4 or 5 guys. Thanks. And who has real application running on top of an OpenShift cluster? Quite a few, okay. Okay, so let's get started.
So, oh, it's my turn, yeah. So basically just a recap, because there are possibly persons who don't know about OpenShift, okay? It's OpenShift v3, it's a platform as a service product from Red Hat, and it's based on containers, it's based on Kubernetes, it's like the productized version of Kubernetes. It uses also OpenVSwitch as an SDN, maybe we'll see that later. It also uses Ansible as a way to install, okay? And of course it covers other technology. Okay, so let's keep calm and use OpenShift. Let's go with the bad.
Okay, then it's my turn. So the bad, as you may see on the next picture, is usually the system administrator. So they are usually the bad guys. They told you not to do that, not to deploy this application and such. Go ahead. So from the system administrator point of view, what OpenShift is, it's like a bunch of new virtual machines or new instances that run some new services that they are not used to do. It includes also a distributed key value database. In this case is etcd, where OpenShift stores all the data. It adds complexity, which is an overlay network on top of your current networking, so you need to have this in mind if you are a system administrator, because your networking is going to be some more messy, let's say. You need also to think about the dynamic storage, so there won't be this kind of things like ask for the system administrator for a volume or for more storage, because it will be dynamically provisioned by the infrastructure itself. And in the end, it's OpenShift, which is from a system administrator point of view, is a multi-tenant platform for developers to easily deploy application on their own. So you just start your platform and then give the developers the ability to deploy whatever they want on the infrastructure itself. So it seems for the system administration, it's quite complicated. It involves a lot of new things. So this is what system administrator will be. So riding a bike, except the bike is on fire, you are on fire, everything is on fire, and you're in hell. But also it's an opportunity to see that the system administration can be the hero that a developer needs. So it will provide you like a real platform to work with. And the first step on an OpenShift platform will be how to install, how to deploy OpenShift for the developers to use. So the first thing is that with just an OC binary, you can create your own OpenShift cluster. It's a minimal installation of OpenShift. You can use your own laptop to deploy it. It's not for production. It means it's just for playing with it. You can use as well Minishift, which is, let's say, the Minikube, but for OpenShift. Then is the official way and the supported way to install OpenShift, which is the Ansible-based installer. There's a bunch of playbooks that you create an inventory file with all the options that you need to fit your platform. Then you run the playbook, and after a couple of minutes, well, actually a little bit more, it will install you like a real OpenShift platform, depending on the variables you wrote on your inventory file. And then we, in Red Hat, and particularly my team, one of the things that we create is those Red Hat reference architectures, where we validate, we test these products on top of different providers. So, for instance, there's OpenShift on OpenStack reference architecture, OpenShift on AWS, on Azure, on VMware, on Rev, right?
On Google Compute Platform.
On Google Compute Platform, yeah. So we apply the best practices, we validate all these steps, and we create those reference architecture that you might take a look to understand how do you deploy OpenShift on the real world. And okay, let's go with the demo.
Okay, so that would be the demo. Okay, just installing OC cluster with this stuff. But you know, in the real world, we do real demos. So let's connect to a virtual machine, actually. Okay. And we will deploy OpenShift over there. It will be easy, but just so that you see. Let's hope I can connect. Okay, so I will run this script that I've prepared to demo. Okay, so the first thing, we will just grab the IP of this virtual machine, and then we will create our cluster. Okay, so basically while it launches, I will explain a little bit what it does, because it takes a little bit of time, this part. So I already installed Docker just as a requisite on this virtual machine, okay, and some requisite prepared Docker. And then I also installed the OC tool. And then basically, I'm launching this installation. It takes like 20 seconds, okay. Also, I did a couple of parameters, just for instance, this public host name with the IP, so that I can actually connect to the UI, for instance, directly without having to wonder about IP things and so. And once it's done, you know, I can just log in using this command and system admin, and then we can check the pods. You can see that they're already running, so there are some pods like Docker registry and the router to provide access to the expose service and so on. So it's deployed.
And now we will see a real-world installation, just instead of the OC cluster app. So let's connect to this Bastion host that I've deployed a couple of days ago. And as you may see, there's a bunch of nodes ready for hosting application, right? So in this case, I follow the OpenShift on OpenStack reference architecture, all the steps. So it ends up with this particular infrastructure. And you will see that there's a lot of pods running on the environment, which includes all the OpenShift goodies, let's say, so login metrics, the service broker, and so on. Hopefully they will be running. Exactly. So this is a basic, let's say, a basic installation on a production environment where all these pods that provides OpenShift out of the box, right?
That's it.
Let's continue.
Okay. Oh, it's my turn again. Okay, so just again, some recaps on OpenShift versus Kubernetes. Okay, so as I mentioned earlier, OpenShift is based on Kubernetes, but the goal is to provide some stuff on top of that. So basically, with OpenShift, you get like an easy installer. It's based on Ansible. It eases supposedly the way to deploy OpenShift and Kubernetes. Then you have also networking plugins. So you get an SDN created using Open vSwitch when you deploy, so that you have connectivity between your containers, between your pods. You also get a web interface so that the user, the developer, can easily deploy its application. You have this template system. Security is an important part. Like typically, you don't want your containers to run as root, so you want to have like those rules that enable you to decide a little bit who can run what. Let's say, of course, we have, like Edu indicated earlier, metrics and aggregated login. You have this build feature, which is important because you want, for instance, to provide the ability to the developer to possibly launch or deploy its code from a GitHub repo. You just point to a GitHub repo, and basically OpenShift will create the necessary containers, so you don't have to really get into these container things. You just want your app to be deployed and use this fancy containers element, and then there's other stuff. Now let's go with the ugly part.
It's me
I
again.
don't mean Edu. Just ugly.
Yeah. So we have like a background of consulting. When we started at Red Hat, we started as consultants, so we have seen things that, well, we can talk about it, but we have seen nasty things, and the idea is to provide you some feedback on to do things well from the start, right? So this is a typical joke about the consultant. When you go to a customer and you see what the sales guy has told the company what a product does, and you need to figure out how to fix it, how to make it work, right? And a disclaimer, this is based just on our personal experience, so it depends on your company or wherever you work, your mileage may vary, right? So this trend of digital transformation and all these buzzwords with OpenShift actually is one of the things that I felt that this is real, right? So you need to involve a lot of teams that will use OpenShift or to deploy OpenShift. So companies like big banks, where they have their networking guys, the storage guys, the security guys, the infrastructure guys, you need to mix or create a new team with people from all those departments to be able to provide a successful OpenShift environment, because it involves a lot of technologies that we have talked about before. And the phrase here is that it will change the way you create, deploy, and maintain your application. And this time, it seems to be for real, right? So it's important when you talk with a customer, even if you are not a consultant, but you are acting like a consultant on your own company. So, for instance, you're going to be the one that is going to provide the OpenShift cluster for the company. You need to set expectations and milestones, have things in mind, how will take to provide a bunch of IPs to the instances, how long can it take for the storage guys to provide like a dynamic storage backend for the OpenShift to use, and polish those raw edges. So, for instance, there was some customer that they didn't want to use Ansible, but the OpenShift is deployed using Ansible, so it will take a lot of time to engage them with Ansible and make them understand how it works. Use the reference architecture. That's what my team does, so please use it. Are a good reference on how to do things. We try to do our best to provide you an easy path to deploy OpenShift on the real world, best practices, and things like those diagrams.
Great diagrams that they can do, I can see.
But the thing with the reference architecture is that even we try our best, there's no reference architecture for the real world, right? So you need to understand how it works, and you need to adapt to your company and your environment, right? Because there will be things that actually don't match, right? So when trying to deploy OpenShift and you're planning your architecture, you need to think on those new things that OpenShift provides you. So you need to think about what kind of storage backend are you going to use, or you're going to give the developers the option to use. You need to think about, for instance, the authentication backend. So maybe you need to integrate it with your enterprise LDAP server, or maybe you want to just for development environment, you just want to create the users by hand every time you need to create one. You need to decide also on those options, for, like the networking plugin. Maybe you want to isolate all the pods within your project, or maybe you, for the development environment, you can use like the regular plugin and all the pods can talk with each other. So maybe for production doesn't fit, but maybe for other environments fit. And you need to think about the overall architecture. If you want to deploy on a higher availability architecture, if it's for a production environment, it's 1% sure that you will need some high availability architecture, but maybe for the development, it's not required. The thing with OpenShift is it's quite flexible. It can allow you create just one virtual machine and deploy everything on it, or you can create like a big platform. But it's usually a good idea to start with a solid platform and a high availability in mind. So in case you need to add new nodes or increase your platform, you can do it actually quite easily with the OpenShift Ansible playbooks that we provide as well. And you need to think big, right? You need to think that this environment will grow up easily, because when developers will use it, they will see how it works and the benefits of using OpenShift, and you will actually see you creating new nodes quite often. So this is a list of general recommendations. I won't go too deep on this. This is just a quick list of general recommendations.
Like time sync, yeah, but you have to mention we missed DNS, which is always the issue.
It's always DNS, exactly. Yeah. And the most important thing is you need to automate all the things. When you need to modify some parameter on all the nodes that you have deployed, you need to have this automated, because otherwise you will be fucked.
Okay, so now it's time for the good part, Clint Eastwood. Okay, so with the good, we mean developers, right? So what we mean with that is that Kubernetes, OpenShift allows you to use some good pattern when developing. Okay, so I'm going to focus on two use cases that I like. So first is the quick deployment that we can do with application, and then we will see a more fancy maybe use case using custom resource definitions and custom controllers, which I had a look at it. Okay, so quick deployment of application. When you're using OpenShift, you can use OC new app. It's your friend. It's just some tool on top of kubectl, I think it's called, kubectl, which allows you to quickly deploy your application by wrapping all these Kubernetes objects. Okay, so let me just do a quick demo of that. I will deploy a sample app based on a dummy container that I've got hosted on docker.io. I think it's this one. Okay, so basically we are creating a new project called dummy. Now we will launch this deployment based on this container. So you can see that just by running this command, I've created this image stream, but basically I'm creating the pod, the service, deployment. It's called deployment config because it has like some difference. And then, I'm exposing the service too, okay? Then if I click intro, OC pod, you can see it's running. It's a dummy app with some troubleshooting networking tools. Okay, so quite easy. Now we can also do more advanced stuff, for instance. So custom resource definitions, it's a Kubernetes object. Basically, it's the successor of third-party resources. And what it provides you is the ability, an extension of the Kubernetes API, which, to put it simple, allows you to create your own Kubernetes object type, like they do pod and so on. You can create whatever you have in mind, cron job maybe, or guitar, which is what I'm going to demonstrate. And then we would operate on top of it. Okay, so that's what a custom resource definitions look like. Okay, so I'm defining my new type called guitar. I'm using the specific domain, and then I can use this short name. It's pretty much the same. Once I've done this just once, I can create then my guitar objects. For instance, a Stratocaster for people playing guitar. Okay, and I can add my own attribute. For instance, the brand, it's from Fender company, and the review, and so on. Once I've done that, typically what I would create is a custom controller, which is basically a program, a loop program, which is continuously watching the Kubernetes API and just operating whenever someone adds those objects, those guitars, for instance. Okay, it's a cool pattern, and I like to insist on that because it's like last 8 months, I've seen it apply to a lot of different projects, like in serverless stuff, OpenFast, Fission, and also see that, for instance, internally we use it in KubeVirt, so it kind of repeats itself, and I think it's quite easy for Python, at least developers or Go programmers, to do it. Okay, so since I have time, I will demo this stuff, for instance. Clear. So what does it look like? Basically, let's create a dedicated project. Then we will give privilege. I was talking about security, so out of the box, that doesn't work. We have to add extra privilege because this controller that I've designed in this case, I want it to have access to all those guitars in every namespaces, basically. So just think in terms of your own application, what it would look like. Then we are deploying our custom controller. So again, we are leveraging the OC new app tool, right? We're just pointing at an existing controller that I've got hosted on Docker.io. So we will check that it's there. Yes, it's running. It got deployed. Okay. So it's watching now and just waiting for new objects to appear. So yes, I have to go quickly. That's fine. So it's a guitar, just a guitar. Okay, Les Paul is another brand. Another guitar, the Stratocaster again. And what we will do is we will create this object, those guitars, the same way that we would create other objects in Kubernetes. Okay. Yes, I'm creating one more. Out of time, okay. And basically what we want to see is that, just have this quick look, we can see that our controllers actually did something, basically. You know, it updated, you know, the command, for instance, and put like that the Fender was a great instrument, and like the Epiphone, another brand, is not so good. So basically, that would be that. And then I won't do it because we're running out of time, but we can create a new UI also that we just consume the CRD, the custom resource definition, and then just enjoy them. Okay?
Okay, so any questions?
Questions? No one? No?
Sorry, I didn't get why I need this guitar.
The?
Yeah, we create an object guitar and why I need it, why it's useful.
Because he's crazy.
The question
He's
was,
a guitar fan, so he always talk about the same stuff, right?
let me just repeat the question. So the question was, why did I create those guitar objects? Okay, well, I like guitars, of course, but the other reason is that you just took part and you define your own objects regardless of these etcd things. You don't understand. You don't have to understand etcd. You just map your object using the API of Kubernetes. Of course, you don't want to use guitars, but maybe you want to use something else, you know, depending on the type of application that you're using. So by leveraging the Kubernetes API, you can use that directly without having to go into the deeper elements of a key value data store. So it's abstraction, what you get. More question? Go ahead. No? Okay, so we're done.
Okay, so we're done. Thank you so much.
Esta me ha gustado. Did I really run a lot of